Okay, so today the topic at hand is an introduction to a database system called MongoDB. I would start off by saying the more I personally have learned about Mongo, the more I have become a fan. So in the space of databases, it's safe to say, just as an individual, I am a Google fanboy. You could describe me as that. I have lots of Google products, Google phones, Google devices. I fall into their ecosystem, and that's my personal preference. When it comes to databases, you could also describe me as a Mongo fanboy. It's not the first database system I learned, and it's relatively newer, but I've become a fan. And so we can begin this conversation talking about popular technology stacks. Now, by the way, on the first slide, I recommend following MongoDB on YouTube. So I do have a link for everyone. If you are like me and you learn from YouTube, they have a great YouTube channel. I recommend the follow because again, I have learned a lot from their YouTube channel. So give it a follow, and that's how we would start.
What was the name again?
The link is right on the first slide. So it's going to be MongoDB.
SQL.
So here's MongoDB explained in 10 minutes. Maybe that would be a better maybe that would be a better jump start. But I'm going to recommend we do that maybe after we go through right there. Okay, so to understand MongoDB, you have to understand it's a part of a technology stack. So a technology stack is a group of related technologies that work well together, right? So maybe you've heard of some different technology stacks, but to go through them, there's what's called the LAMP technology stack. You can kind of see there Linux, Apache, MySQL, and PHP, or Python or Perl. This was and is open source, right, for web development. And so, for example, WordPress. WordPress is built on top of PHP and MySQL, Apache, and Linux. WordPress as a platform, as a content management system, crazy popular. Like if you go to wordpress.org, they make claims about their popularity. It's probably not as common anymore, but it used to be like, a lot of percentage-wise of websites on the web were built in WordPress. Call it 50%. I'm just making that up, but they've made claims to being crazy popular for building a tool for building websites on the web built on top of the LAMP technology stack. Again, this goes back to 90s. It's old. It's been around a long time, but it's popular. Then you get into the JavaScript world. And the big difference between mean and MERN, is that third letter, Mongo Express Angular in Node versus Mongo Express React in Node. So the A for Angular, R for React. We are studying MERN. React today, 2023, more popular than Angular by usage statistics. So if you're just looking at what's being used more, it's React, and that's why we're studying React over Angular. But these are two what you would call JavaScript technology stacks. JavaScript being the dominant technology of the past 10 to 15 years. So if you had to learn one, technology stack that makes you the most marketable, my understanding of the current landscape is you want to learn MERN because, again, it is just the most in use technology stack. And then, you just have a couple other technology stacks. Moving on, you have Java is another big one. I kind of skipped over LEMP. You can kind of see they're just all different variations of something very similar. So LEMP and LAMP are very similar. I guess I should stop and just say, hey, Django. The main difference there is it has a different database on the back end. And so you would just see that the database is a piece of the technology stack. And it's a piece that plays well with the other pieces. So Mongo is what plays well in JavaScript world. So in both mean and MERN, you're looking at having a Mongo backend. Postgres is also now Postgres is not one that and MySQL. So MySQL and Postgres, these are two different database systems that are pretty popular that we don't hit because we hit two very popular database systems being Mongo and Microsoft SQL Server. But you can see Ruby on Rails also has Postgres, and then we've got the .NET technology stack. This is Microsoft world, right? So when you see .NET, I just think of the Microsoft technology stack. And then you've got Java. Java is also old, popular, but it's been around since the 90s. Right, so Java has a lot of enterprise support. A lot of corporate America is built on top of Java applications, and so you get into a Postgres world. You get into an Oracle database, which is you can kind of see you've got some flexibility about your databases there. These are three different database systems that can all play nice with Java. And again, just because we're talking about mean and MERN, well, we talked about React for the front end. We talk about Angular for the front end. There's another big one called Vue. That's another front end framework built on JavaScript, and they come out with front end frameworks all the time, right? Another one that is kind of new is called Bun. Not super familiar with it. But this is another kind of, they come out with these front-end frameworks, they come out with these frameworks all the time, and keeping up with them in itself can be a challenge, but what have you. But these are all three just front ends on top of JavaScript. Okay, so let's get into Mongo. Okay, so understanding that a database system is just a piece of a technology stack. A technology stack is just a group of related technologies that play nice together. They can work together. Okay, so we're learning Mongo. It's a piece of a JavaScript environment technology stack. And so if you look at the history, of database systems, go back to the C# world. What did we learn about in C#? We learned databases in C#. I'm sure you guys at least remember, you say, oh yeah, we worked a little bit with databases. The databases that we worked with look like this. Like if you remember looking at these tables look like Excel spreadsheets, right? And we talked about the differences between Excel spreadsheets and these tables, and when you're working with databases that look like this and they have these tables, the history is that these are called relational database relational database management systems. RDBMS, relational database management systems. Hey Max, you said 2 seconds in here you are taking notes. You're engaged. We're like 5 minutes in. Kudos to Max.
Do better than what I can, okay? Do better than me.
RDBMS, Trey, what does it stand for? RDBMS.
No.
See, maybe I just need to be more engaging.
Exactly.
So I'll engage you, and that will force your mental. So anyone that was just paying attention, someone hopefully, RDBMS. Relational. The DB is database. MS management system. Thank you, James. Relational database management system. So going back in our list of databases, Postgres is a relational database. MySQL, where was MySQL? MySQL, relational database. Okay, just a category. SQL Server, relational database. Okay, what does it mean? See, you're asking for it, Trey.
I'm ready.
Trey, what does it mean to be a relational database?
Some data from another database can be connected over to another.
Very close.
Correct.
You said from one database to another database.
Yes, that's it.
It's close. One table relates to another table.
Correct. I was on the right path.
You're on the right path. This is important, right? Relational databases. Why is this so important? Applications have used relational database systems ever since since the 70s, 60s, 50s. So if there's been an application that's ever been built, odds are it was built on top of a relational database. As Trey just explained, relational databases means that tables are related to one another and tables are linked together. Relational databases means that your tables are linked together. So here we have this orders table, and notice there's an order ID, 1, 2, 3. Okay, and notice this order item has an order ID, 1, 1, 1, 2, 2. These two tables are just linked together through this column, order ID. When tables are linked together, that makes a relational database management, a relational database. When tables are linked together. Mongo is not a relational database. So relational databases are old. I'm gonna pull up the wiki on relational database wiki. I'm gonna show you how old this concept has been around since I was guessing right, 1970. Okay, this concept of storing data has been around a long, long time in relational databases. Okay, before relational databases, everything was in flat files, just like your CSVs. What's a CSV? I gotta ask more questions. What's a CSV? I'm gonna call on you if you have your phone out. How about that? What's a CSV if your phone's on the table?
A comma separated value.
What is a comma separated value?
A text file that has a specific format which allows data to be
Yeah, it's a text file with data in it. It's a text file with data in it separated by commas. If you got to answer with Wikipedia, I don't care. You gave me an answer.
I answered with Google support.
That's right. Okay? Before relational databases, everything was just stored in flat files, and they're like, yeah, that's not super efficient. We can store data in these different tables and then link the tables together, and there's a lot of efficiency that you get out of doing that. Okay, we talked about those efficiencies last semester, and we'll talk about it again next semester. We're not done talking about relational databases. They're not gone. Yeah.
Is it like an array?
Okay. a table, because you said, is it like an array?
Yeah.
So what is an array? An array is a piece of data, it's a thing. When you have a bunch of things, you store that in an array.
Yeah.
Okay? When you have a bunch of students, you can store all your students in a student array. Okay? So when you have a thing, you store that thing in an array. An array is ultimately stored in RAM. Okay? What happens with RAM when you reboot? It's gone. Right? You're writing a Word document.
A table keeps it.
A table keeps it.
Okay.
Okay? When you save that array into a table, each thing is a row in the table. So each student would be a row. Yeah?
Yeah.
Steven just asked a really good question. And I want you guys to realize, if you store your array in a database, you're essentially looking at a table is kind of like your array. And each array element is a row in the table. Okay? Good question. Now, Mongo is called a NoSQL. All right? So, term number one, relational database. Relational database means you have tables and they're linked together tables. By the way, if you want to get more technical, they're linked together through their keys. Do you guys remember these terms? Primary key, foreign key. Shake your head, yes or no. Do you remember primary key, foreign key? Yes. At least you remember the terms. Okay, tables are linked together through their keys. I want you to look at the slide here and see what a NoSQL, how NoSQL saves information in a Mongo database. So MongoDB is NoSQL. What does NoSQL mean? It's actually very poorly, it's poorly named. NoSQL is poorly named because what NoSQL really means is that we're storing information without related tables. That's all it really means. NoSQL, and we'll get more technical, okay? But for right now, you have relational databases, which are linked tables together, and then you have NoSQL. NoSQL just really means non-relational. So you've got relational databases and you've got non-relational databases. And if you're looking at this NoSQL, I mean, it's a JSON object. This is JavaScript. The JavaScript objects that we're storing in a Mongo database, it looks just like it does in JavaScript. That's why it's a part of the technology stack, because they play nice together. Let me just log in, okay? I'll log into my, and you guys will make accounts here on mongodb.com. Okay, but let me just log into my account here and show you that I can select a bicycle and show you that I can select a bus and do this later. Let me show you what it looks like in the database. Okay? So if I kind of go here and I go here and I look at my users. Like this is a JavaScript object. I mean, you don't see the curly braces here, but you see the keys, you see the colons, you see the values. Right? This is Mongo, and you can see that this is essentially a JavaScript object. Now, what do you see inside this JavaScript object? Well, I've got an array here, right? So you can have nested elements, you can have nested arrays, you could have nested objects. If I go inside like bugs here, I've got this bug object, okay? But if I look at here, I have a bug author. This is a nested object. Okay, so to bring it back to the PowerPoint here, these JavaScript objects that we've been working with, we're just going to store them in our database. Okay, and there's going to be no related tables in the traditional sense of like having a primary key and having a foreign key relationship. What questions do you guys have so far? So like if I'm just looking at this, you know, you have like a product, something's being bought here, right? So think shopping cart, think Amazon. You have an order ID, you have an order order date. You have an array of items, what was actually purchased. Max, are you a question or are you just stretching? Right on. Right, so here's our array of items that were purchased, right? We bought boots and we bought socks and we bought a belt. Here's another order. This order only had 2 items on it. Here's an array of objects. This one had socks and this one had a belt. Okay, so big picture takeaway so far. You know, we've got relational databases and we've got NoSQL databases. And NoSQL, as we'll learn here, what is NoSQL? Okay, so Mongo is NoSQL. It's a bad name. We'll get into why it's a bad name. Paragraph of text here. When people use the term NoSQL database, they typically use it to refer to any non-relational database. Okay, so it's the opposite of relational database. I don't know if opposite is exactly correct, but it's not a relational database. Some people say that NoSQL stands for not relational, while others say it stands for not only SQL. The reason why it's a bad name is that you can write SQL commands against a NoSQL database. SQL is a standard called structured query language. You guys studied structured query language. Select from where? Remember those? Do you guys remember those labs? Select from where? That's SQL. Okay? You can write SQL against a NoSQL database. Now you see why it's a poorly named, right? So if you wanted to say that the NO stands for not only SQL, okay, then it's not a terrible name. But to me, no, you're going to read no as in no, there's no SQL. That's not the case. There is SQL, but there's also other ways to query the data. Either way, most agree that NoSQL databases are databases that store data in a format other than relational tables. Okay, relational tables and NoSQL. And to Steven's point, you know, hey, we're not just storing data in an array, because in an array, you reboot the machine and the data's gone. What we're talking about here, so everyone's on the same page, is the data is persisting, the data is staying. We're not losing state. Yes?
So basically we're handling like actual sensitive like data now because it's like staying.
Sensitive data, yeah, we can absolutely handle sensitive data, but I would just say our applications are more real world now.
Yeah.
Once we're actually saving and persisting our data, every time you reboot the application, you don't lose the state, right? Because right now, you know, we're storing everything in an array, right? But what happens when you reboot the server? Everything's reset. If you added 5 customers, you lose your 5 customers. You're not supposed to lose your 5 customers. You need to persist your 5 customers.
Keep the app running 24/7, and if the app goes down, GG's.
Yeah, if the app goes down, well, yeah, GG's, right? What does that mean? That means, I mean, when Facebook goes down, they lose money. I mean, when an app goes down, when Amazon.com, when Twitter goes down, at the end of the day, your app can't go down because your business can't profit, right?
Or you see, if our app goes down, we lose everything.
You lose points.
Data.
Yeah, you lose. You guys lose points. Okay, is everyone with me? The difference between relational and NoSQL. It's relational and non-relational is how I think of it. Okay, so a common misconception is that NoSQL databases or non-relational databases don't store data well. NoSQL databases can store relationship data, they just store it differently than relational databases do. So data can still be related, and we will do that. We will still have different, they're not called tables in this world, right? Just to confuse you, they give it a different term, but everyone understands what a table is. Over here it's called a collection. Okay, in Mongo, tables are called collections. All right, and it's not to say that there are no relationships between our collections. We will create some relationships, but what it means is they're not strictly enforced. Relationships are not a part of the architecture, okay? Whereas if you're building a relational database, and it's a good relational database, you'll have relationships. They're enforced. There are very strict rules around that. So NoSQL data models allow related data to be nested within a single data structure. And so you have nesting of data over here, and we showed you that. This is nesting of data. You have an order with an array inside of it. As we're going to learn, you can't have that in relational databases. They're called relational databases. Ultimately, your data is stored in a cell, right? Think of an Excel spreadsheet. And there's a term that we're going to talk about that's called scalar. Scalar in relational databases means single value. You cannot have nested things. So this new system, NoSQL, was birthed in the late 2000s. When were all of you birthed? Were you birthed in the late 2000s? Early 2000s? Okay. So a little bit after you guys were born, this thing was invented. So are we, would you all, if you're like identifying yourself, would you say that you're kind of techie?
No.
Would you say you're techie?
No.
Oh, come on.
Yes.
Yes.
100%.
Of course. You're in a tech class. Compared to your friends and compared to your peers, you are the tech guru in your friends. If they have a tech problem, they're probably coming to you. Because if nothing else, you're in school for it.
So is one of my friends.
Well, then you're both the techie people. Okay? Suffice to say, are techie people slow adopters of technology, or are they a little bit quicker adopters of technology?
Say old people.
Are younger people quicker adopters of technology, or are they slower adopters of technology? Thank you. Does everyone agree with that? Younger people are quicker adopters of technology? Okay, so let me ask you, as a student coming into a tech school, and I'm going to tell you this. Hey, I got a technology that was birthed in 1970, and I have another technology that was birthed in 2010. Which one do you want to use? Is there any debate? Right? Most young people want to use the new technology. Most young people are going to say, hey, this thing that was birthed in the 70s is full of some problems. It's old. There's got to be there's got to be a better way. There's got to be a better way. Introduce Mongo. Mongo was created as a system that a lot of people said there's got to be a better way. Right? So you want to ask me, like, why am I a fan of Mongo? is it looked at a lot of the flaws of the old system and addresses those flaws. Okay, and we're going to get into, we'll go through that kind of quickly. Okay, but just, you know, just on surface level, do you want to use a technology birthed in the 70s or birthed in 2010? You're probably going to say, I want to use the newer thing. It's probably got a lot of features. You know, do you want to use a cell phone from 1970 or you want to use a cell phone from 2010? You're probably going to choose a 2010 technology. It's got new stuff to address, you know, make it better than the old. Okay? So you know, let's get into what were some of the flaws with the old system. Okay? Looking at this chart, can you guys see this chart here? Does everyone realize that in the early days of computers, what was a standard computer size? Take a guess. How big was a computer in the early days?
Of course it was teeny tiny.
Yeah, as big as a room, right? So the room that we're in, look around, right? This entire thing would be needed to be a simple computational device. 2 plus 2, you know, 5 times 10. To do simple math, you would need a computer the size of this room in the early days of computing. Probably a little bit bigger, but you're getting the scale. The scale is huge devices, mechanical arms, big cables. Cables like this, right? They would just run across the floor, okay, to get a very simple computational device. It wasn't even programmable in the sense of you have a programming language that you can give it custom commands and make it do whatever you want. Okay, they would have these punch cards that you would feed it and it could do math, and that was about it. Okay, you couldn't tell it to load up Google Maps or whatever. It was math. It was a calculator. Okay, that's what early computers were. So if you look at a hard drive, how big are your hard drives today? Well, on the right, that's called an M.2 drive. That's an internal hard drive for a computer, right? It's about that big, right? It can easily be held. It's like a couple ounces, super light. Look on the left. This was a 250 megabyte hard drive. 1,000 meg roughly is a gigabyte. 1,000 gigabytes is a terabyte. Okay, so that giant device that was as big as the person was 250 meg. Okay, so in general, you know, what this chart shows is that back in the 60s, hard drives were very, 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 very expensive. And moving into today, 2010 and later, hard drive space is very, 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 very cheap. Okay? So this stuff was invented in the 70s when hard drive space was very expensive. Everyone with me? Okay. So what do you think they optimized for? When building a database system, you're storing data on a hard drive. Of course, they're going to want you to store the information as efficient as possible. Like if I'm going to store someone's name, okay? You're going to store your name on a hard drive. You don't want to store it twice. Why would you redundantly store information when hard drive space is so expensive? Okay? You might do a backup. You might back up that data so you don't lose the data, okay? But as far as persisting it on a hard drive, backups were done on these tape drives that look like movie theater tapes. You know what I mean? You guys know the old movie theater reel tapes? Okay, backups were done on that. The hard drives themselves were crazy expensive. So when you're building a database management system, databases were optimized for hard drive space, meaning you're not redundantly or inappropriately storing information multiple times. Okay. Today, software is different. Hard drives are cheap. Bless you. Bless you. So let's dive into this. As storage costs rapidly decrease, the amount of data applications needed to store increased. Okay. Does everyone realize today how much data is being saved everywhere we go? Right? Everywhere there's an application, there's a camera somewhere, right, recording us. Our phones are logging information about us all the time. It's at the expense of our privacy, right? That kind of thing. But the point is, data is cheap, and data is being saved about us in not linear fashion, right? So if you view data going up in a linear fashion slowly, right? Data is being saved about us exponentially, okay? Exponential growth, okay? So much information is being saved, persisting about us all the time, because as you might have heard, data is the new oil. Have you heard that before? Data is the new oil. Oil used to be the most valuable commodity on earth, and now it's information about you. Okay? So data is cheap to save, and it's being saved in a exponential fashion. More and more data all the time. It's really interesting. And so another problem with relational databases is that the way that you had to save data was very rigid. You had to save data in a table like one way and one way only. This is another huge downfall if you ask me my opinion. Okay? You can save data in one way. NoSQL's like, I don't care how you want to save the data. I can take your objects, I can take your data, and I'll just save it in because data is cheap. I'll save it however you want to save it. Okay? Relational databases were rigid. You could save data in one way and one way only. NoSQL databases are like, hey, however you want to save it. Like if I have a student with student information and my different student has different information and my other student has different information, we can store all those students with different information all in the same table or the same collection. Okay? So the data today comes in all sorts of formats. Right? Because applications are recording data all the time, and it just comes in all sorts of shapes and sizes. And that's what I talk about. Structured data, kind of structured data, polymorphic. It can change what, you might save a student and a teacher in the same collection. Like they're both people, so it's kind of like depending on the person, this might be a student, this might be a teacher. We could save it in the same place. Polymorphic. If you remember, object-oriented polymorphism was a big concept there. Okay, so NoSQL databases allow flexibility. However you want to store data, that's cool. Big benefit. I'm a big fan of this. However you want to store the data, cool. Store the data. Now that comes with challenges. That could come with challenges, but it comes with benefits as well. Okay, NoSQL also plays nice with Agile. You guys have heard about Agile from those alumni videos that I've done, right? When I ask what's your day like, they talk about doing sprints. Hey, we have a morning stand-up where we talk about what we're working on today. They give us an objective. We're trying to accomplish this task within a week or a 2-week sprint, right? And then we deliver that to the client. We say, hey, what works, what doesn't work? Okay, so agile development is modern ways that we develop software. So this Agile Manifesto, it's kind of funny because this, I mean, look at this website, guys. Look at this website. It looks like a website out of the 90s. Okay? But the Agile Manifesto was like, hey, this is how modern software should be developed. Okay, so I strongly recommend reading this in its entirety. But again, what you're looking at here is the old way of doing things, was called waterfall. Waterfall was a very rigid process where you would follow steps in a waterfall fashion. You would do step 1 first, and you would complete step 1. Then you'd go down to step 2, complete step 2, and then go on to step 3. Complete step 3, go down to step 4. So if you're kind of like you're coming down some stairs or going down a waterfall, you're not going back up. Okay? So if software development can be simplified into a series of steps, Agile is very different. Agile is going to be, okay, we're going to do steps 1, 2, 3, 4, 5. We're going to iterate over them in a week time. How fast can you go? Let's do a sprint. Jacob, how fast can you do steps 1 through 7? Max, how fast can you do steps 1 through 7? Let's sprint. Let's complete all 7 steps. Let's show it to the client and let's get feedback. The client says, change this. Okay, let's do another sprint. Let's get a product up and running, bootstrap a product, minimum requirements, minimum software requirements, show it to the client, get feedback, make changes, show it to the client, get feedback, make changes. You're going through steps 1 through 7 many times, over and over and over, and as fast as you can. That's why it's called a sprint. Okay? So in this world, we're building full stack applications. Like a sprint's gonna be, how fast can you build a full app? How fast can you build a full stack application? Let's build it in 2 weeks and show something to the client, minimal requirements, right? And then just iterate over. Okay? It's a more scientific method, okay? Of like, let's do something, let's build something, let's prove something, and iterate. So they talk about individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. These are principles of Agile. That is, while there is value in the items on the right, we value the items on the left more. Okay, so again, when you go to work in this industry, odds are they will be following an Agile methodology, hopefully. Unless you work for the government, then they're probably doing some waterfall stuff, right? Because government is slow and old to change, and in the old days of software development, and I don't know if any of you guys are old enough, I don't think you are. In the old days of software development, you would build documentation like books. And I remember some of the video games that I got as a kid, and the manual for the video game was thick, very thick. And because in the old days, guess what? You shipped a Nintendo 64 cartridge or a Nintendo cartridge out the door. Could you patch that? No, you couldn't patch that. You had to ship a finished product. Okay? You had to ship a finished product. It needed to be as clean of bugs as could be, and people needed to know how to work with it. And so you would spend so much more time on documentation. Okay? Documentation is important, but it's not as important as what's on the left, as they outline working software. Okay? So because here's what happens, and you guys have never you've never really built a whole lot of software. So what happens in the real world is people say, oh, I want you to build A, B, and C. You build them A, B, and C, and then they go, no, I want X, Y, and Z. Then you build them X, Y, and Z. No, I want A, B, X, Y, and M, right? The point is, requirements change all the time. You have to be agile. You have to be nimble. Okay? Because you can store data however you want in a Mongo database, this is a database system that is agile and nimble. Right? So as the requirements change, so does your database can change. Your database can change along with it. All right, let's take our first break. So we're moving forward into an upgraded system, if you will, from a relational database. So I don't want to focus too much time, although we'll give it a little bit of time, on what were the problems with relational databases. Again, we're not working with them, and I don't want to focus on this, but let's just talk about, again, some problems with the old that we're not using the old here, we're using the new. Relational databases were designed for a world where hardware was expensive. Right? I showed you in that chart. Hard drives used to be way more expensive. Of course, RAM, when it says memory, RAM was more expensive. Every person that's older than you, myself included, could say, I remember when a stick of RAM used to cost, okay? And I'm going to give you my version of that story, not that you guys care. I grew up playing the game EverQuest 1, okay? This was a game of the late 90s, early 2000s. It was an MMO RPG.
What was your class?
I was a rogue.
Bet.
And EverQuest has zones. You would go from one zone to the next, and in between zones there were loading times. And so you'd go from one area of the world to the next. My computer had 64 megabytes of RAM. And my zoning times were of the 5 minutes in nature to go from one zone on my computer to the next. I would leave, go to the bathroom, get a drink of water, come back, and I would still be zoning. Okay, I went to my local Best Buy. I bought a 128 megabyte stick RAM upgrade to upgrade my 64 plus 128 to get you the 172. Is that right? 172 megabytes of RAM. Right? And my EverQuest load times, and that stick of RAM probably cost $100. Okay? And my EverQuest load times went from 5 minutes to like 30 seconds, and I was the happiest, freshman in high school that existed on that day.
You were a happy young G.
I was a happy young Mr. G, yes. Or happy young G makes it sound kind of gangster. I was a happy young G. Because my load times went from 5 minutes down to 30 seconds because I bought a 128 megabyte. Now, how much RAM do your laptops have?
64.
64 gigabytes.
1 megabyte.
64 gigabytes, and is so much cheaper nowadays. So yes, RAM was more expensive. Hard drives were more expensive. Guess what? Software engineers were cheaper than the hardware. I love this statement, right? Hardware is a replaceable commodity, okay? The value today is in the programmer, okay? Our industry is where all the value resides. What we build with our software is how society is leaping forward, okay? You could say, okay, self-driving cars are here, they're not here, whatever, but it's the software developers, building AI. Okay, Tesla does have their AI, computer vision, that's changing the way that society works. Okay, software were cheaper than hardware today. Today that's not the case. Software engineers were seasoned employees of the company. Tell me about the job nature of today. Do software engineers tend to stay at one company, or do they job hop? They hop. It's the old days where an employee would stay with one company for 40 years. They would be loyal because those companies had pensions, and they would promise you a comfortable retirement. And if you stayed with us for 40 years, we'll pay for your retirement. Companies don't have pensions anymore. They don't. You can take your retirement with you. It's called a 401k. Right? So why have loyalty to one company, especially when they're just going to give you a 4% pay raise? But if I take my skills over to this other company, they're going to give me a 50% pay raise. Right? You stay loyal to one company and they give you 4% year over year. But if I job hop, I'll go get 50% 1 year, 3 years later I'll get another 30%. I'll go, double my salary sometimes. That's how your salary tends to balloon higher, is you job hop. You gain a set of skills, you stay with the company for 1 to 3 years, you gain a set of skills, you move on, right? Your skills plateau, you move companies. Your skills plateau, you move companies. Your skills go up and up and up. Your pay goes up and up and up, right? You're a nomad. Software engineers, I've even heard it called the round robin effect, where you go from company A, B to C back to company A, but you're making like triple the way what you used to make at company A.
I just call myself like a rich hobo.
Yeah. Even more than that. You talk about being a rich hobo. I mean, if you're really, really, really good, 9 out of 10 software engineers are at least hybrid. Many of them are fully remote. I mean, you could travel the world writing software. I mean, you could truly not have, but you have to be really good. You can't be just okay. In the old days, you didn't need that many users. Okay, now let's use an extreme example. Facebook. How many concurrent users does Facebook need to service? Millions?
At least one.
At least one is correct, right? Maybe 2.
Okay, no.
Internet didn't exist. Hard drives could only do read writes efficiently due to seek time, right? So if you had to look up information, right, reading information off of disk took longer. But SSDs changes, right? Mechanical drives versus solid state drives, more electronic. Business requirements today are always evolving and always changing. So this was the old days. Today you need to handle thousands of users. You need to handle millions or billions of records. You need to be geographically distributed. I mean, software is global today, supporting multiple languages. Hardware is cheap and developers are expensive. You can read data much faster today than you could in the old days. Business requirements are not well understood. Let me tell you something if you haven't heard this from me before, okay? You guys ideally will graduate and get a job, okay? You will go into an industry. On average, you guys are 18 to 25, right? Probably by the time you graduate, you're going to be 20 to 27, okay? You're going to be young. Industry, business is complex, okay? It is to learn software development, that's one learning curve. To learn business and to learn a particular industry, that's a whole nother learning curve. I've had no shortage of alumni come back and tell me, Mr. G, the hardest thing about my job is not how to code. The hardest thing about my job is understanding the business so that I can solve a problem for that business. Okay, an example of that is I had a graduate go work for Anheuser-Busch. Obviously, they make beer. Okay, to make beer, there is a process for making beer. Okay, it is a different process for making beer on a global scale. Okay, the temperature controls, the systems that are in place are all highly regulated. That beer needs to taste the same every time. Right? Bud Light needs to taste the same. Bud Light in Florida, Bud Light in Missouri. That Bud Light needs to taste the same. So they have highly regulated systems by that company. Okay? Understanding those systems can be harder and oftentimes is harder than understanding how to write software. Okay, so to understand the business and the requirements of the business, developers generally don't understand that well. That's why they say there's a huge disconnect between what businesses need and the software that developers develop. Have you heard that before? Has anybody ever heard that before? There's a disconnect between business and software. You've heard that before. Good. If you haven't, you're hearing it now. There's a big disconnect between what we build and what they need. because we don't listen well and we don't understand. Right? Stereotypically, we're not people persons.
We're aliens.
Right? And so because we don't understand people well, we build what we think is best, but what we think is best doesn't actually function well for them. It's like if you're a highly sociable person in this industry, you're kind of like a unicorn. And there's value in that. Okay, business requirements are constantly changing. Okay, and even if you do understand the business today, it'll evolve and be a different business tomorrow. Okay, problems with relational databases. They have auto-increment. Auto-increment is full of problems. You guys remember student number 1, student number 2, student number 3, student number 4, student number 5. Those are the IDs of the students. Why is that a problem? Well, there's a bunch of problems with that. Number 1, I can predict your student number. If I know that there's 500 students, I can tell how successful of a business are you. You've got 500 customers. Okay, you're a certain level of business. Right? It also makes you easier to hack. If I know that you're just auto-incrementing, I know that there's 500 numbers that I can try and attack. That I can try and hit your database and say, give me student number 5, because I know there's a student number 5. Right? So auto-increment is full of security flaws, security risks. Right? Can be easily guessed by attackers, reveals usage statistics. Okay? And if you've got servers across the globe, you got to say, okay, well, I just made number 6. You got to make number 7. You got to make number 8. You can't make multiple number 6s. That requires synchronization. Synchronization takes a little bit. It takes some time, right? It's processing. So it's slower. It's slower, right? So there's speed, security, and all sorts of problems with auto-increment. Mongo doesn't have auto-increment. Okay, auto-increment is what we used last semester, but for these reasons, auto-increment's not good. Okay? So we're not going to use auto-increment. Foreign key constraints. A constraint is a rule on the data. Okay? And remember when we said we had these keys, and these keys set up relationships between tables? Again, foreign keys also require synchronization between servers. That's a speed issue. It locks multiple tables during both reading and writing. So if you have multiple records that need to be written, it can take a while. This is also a performance issue. So you would say these two are for performance reasons. And when you're storing data in multiple tables, guess what? You want to bring all the data back together. That's done with a join. You guys you've written joins. You've been tested on joins. Joins are a semi-complex thing to write, and again, bringing data together from multiple tables is a performance thing. So I would say all 3 of these are performance factors of reasons why foreign key constraints aren't the best thing. And ultimately, there's a fun term here. Tables do not allow for nested documents and arrays. I don't know why I find this term fun. Scalar values. There's a term that means a single unit, basically, a single unit of data. Relational databases have scalar values, meaning every cell is a single value. You cannot have a nested thing inside of that cell. You can't have a nested object. You can't have a nested array. But you can in Mongo. Right? You can have remember we have keys and values. We have keys and values, and a value can be a nested object or a nested array. As we demonstrated back here, in this slide back here, we have a key, which is items, and the value is a nested array. Okay, so Mongo databases aren't scalar, whereas relational databases are. So those are some problems. Here's another one. You could say object relational mappers are a problem because they kind of abstract the layer from you. Again, that's going to help you tie in your application logic to your database. And we have used and will use again ORMs. But you can read the definition here. ORMs are frameworks which provide a layer between the database and your code. ORMs kind of map operations together to tie in the database to your application. They remove the need for developers to actually write SQL. However, if you've ever had a piece of software write code for you, there's a good chance you might not be happy with the code that it writes. Did you guys hear me on that one? If you've ever had an application write code for you, there's a good chance you don't like the code that was generated. And so that's what an ORM is. ORMs will kind of automate some code writing for you, but you might not like what it writes. Okay, so a lot of these systems have ORMs, and a lot of people don't like ORMs for that reason. Yeah. And finally, a lot of databases do not support a JSON data type or an XML data type. Some do, some don't. It just depends on, is it MySQL, is it Microsoft SQL Server, is it Oracle, is it Postgres? These are all different database systems, and many of them do not have built-in data types for XML or JSON. Well, why is that a problem? Well, that's how data is transported on the internet. Data is transported on the internet in one of these two formats most likely, XML or JSON. So why not just accept the data and store it in the database in that format? Okay, here's a slide. In the end, and this is my opinion, so this is an opinion slide, relational databases are not optimized for today's applications. Relational databases cannot handle more than a few thousand concurrent users. They're not optimized for distributed database systems. Again, there's performance issues when you have distributed database systems. And they're not optimized for unstructured and nested data. Many don't even support it. Okay? All right. That's the old system. Again, we're not kind of focusing on the old system, but there are some flaws with it in my view. Okay, so here we have MySQL, which is a relational, I would even say relational MySQL versus non-relational MongoDB. All right, so we're going to have a face-off here. All right, we've got two database systems, and we're going to compare them. Is everyone with me yet? Come back in, zone back in. Now's a good time to zone back in. Okay, if you find yourself off track,
We're so bad.
come on back. So we have some terms in non-relational versus relational. Relational versus non-relational. The first one's a funny word, and as long as I've been in this space, I'll be honest with you, I've always found its definition a little cloudy. What is a database schema? And I can Google it just as well as anybody else can. Okay, before I hit enter on this, okay, database schema definition. A schema is the overall architecture of a database. How the data is stored at the big picture. Okay, so what are the tables? How are the tables related in a relational databases? You know, what are the collections? And how do you store data at a big picture on a non-relational database? Okay, A database schema defines how data is organized within a relational database. Okay, I think I hit that nail on the head. How the data is ultimately, I guess I missed a key word, organized, right? How many people define themselves as organized people? No?
Depends.
Depends on what it is.
Yeah.
Depends on what it is.
My desk area, yes.
I know
Everything
where
else, no.
everything
My desk area, no. My
Is
code,
that-
yes.
My code, no. My desk, yes.
I don't know.
Mine is, but then like. my
I don't know.
desk is in-
Everything
Oh, I have my code.
And I
That's gotta be there. My duck's gotta be over here.
Yeah. If it works well for you, does it need to work well for others? I don't know.
Yes.
Maybe depending on what it is, right?
My mother's OCD says otherwise.
So let's right.
When-
So let's talk about database organization, right? It's safe to say you can have organized databases or unorganized databases, which is ultimately saying how do you store information, right? When I took database courses in my, educational path, the organization of data is something that I personally struggled with. I will share that with you guys. I had my database teacher, maybe I got an A in his class, but he'd look at me and he'd go, Evan, you got to work on this. You got to think about this a little bit more, right? And so how do you store data if you think of an old system, you got a filing cabinet, you got folders, these kinds of things. That's a way to organize data, right? The data is ultimately on a piece of paper, in a folder, in a filing cabinet that you can access and retrieve it quickly, right? Or not. So you can store it. At the end of the day, this winds up how you organize the data leads to performance. You can have good performance or bad performance based on the organization of data. So schema, I'll even put in here, how the data is organized in the database. So the term schema relates to the same term schema. So we're going to use the term schema the same across systems. Okay? However, in the relational world, we have tables. We don't have tables. I mentioned that earlier. They're not called tables anymore. They're called collections. We don't have rows anymore. Inside of a table, you have a row. We don't have that anymore. We have documents. A row equals a document. If you follow politics, this is where my brain was when I woke up from my run this morning. I'm going to make a political joke. It is just a joke. Don't get offended.
I like these kind of jokes.
Okay? And this is a dad joke. It's not a good one. It's a dad joke. Okay?
Better.
Even better.
Do tell.
Okay. What did Donald Trump just get in trouble for? A collection of documents. Ba-dum-bum. A collection.
You gotta drink coffee for that.
Bro, that's awesome.
Thank you. I got
That's
one. Yes.
awesome.
Normally I don't do pain and dad jokes. That one hurt me.
That's awesome.
That one, I'll have to
A
go-
collection is what? A collection is the table. If it helps you remember the terminology, I'm cool with that.
That's gonna help me remember now.
If it helps you remember the terminology, that's what I was going for.
That's gonna help me so much. Thank you. I need that.
But if I had to defend him, I would say so many other politicians as well, right? He's not the only politician that collected documents. They all have. Okay.
You want to do schema on the non-relational and just hit enter because it's kind of misaligned now.
Yeah, I screwed that up, didn't I?
It's really misaligned.
Okay. I guess we don't need to define it here. It's not super critical.
There,
Okay.
it's back.
Was that like driving you insane or something?
Yes. Like I'll go from one side, next one I'll go diagonally up. I'm like, oh my gosh.
So the table is a collection. The row, Steven, you said what about an array? You have array, you have elements, right? And element 0 is a row. Well, element 0 here is a document. It is a single object. Right? A JavaScript object is a document. Inside of that, Inside of an object, what do you have? You could call it keys, okay? But another term for a key is a field. On the left-hand side of the colon, you have a field, colon, and then you have a value. The value or the property. Okay? Terms are so...
Vocabulary.
Yeah. Terms are... The challenging thing about this, you could also call this a JavaScript object. You could call the field the key, and you could call the property the value. Yeah? You know, the collection is the table.
So by JavaScript standards, the collection is more or less like a permanent array then.
A collection is,
It's the array that holds.
it's the array identifier that holds the array. Yes.
Okay.
Yes.
All right.
Yeah, I like that. A collection could be the array itself, right? The document is an object in the array. The field is the key, and the property is the value. Okay? Okay, schemas. How data is organized in the database, it's flexible. That's the best thing. It's flexible. Hey, today it could be one thing, tomorrow it could be something else. The business is one thing today, tomorrow the business change. You guys have seen examples of businesses changing, right? Twitter went to X, one thing, right? Google used to be a search engine, now Google sells phones, right? Businesses change. So hey, you don't have to define a schema. You can add collections and fields when they're needed. Like maybe today I'm saving certain information about students, and maybe tomorrow I need to start saving your information about your parents. I don't know. Like at first I didn't need your parent information, but now I'm taking Parent Plus loans, so now I need parent information. So my documents can store different things. Over here they can't, right? They might have very strict requirements on what you can store and what you can't. So over here, what this boils down to is that the application can handle changes easily, and over here, your application breaks if the schema isn't exactly what expected, right? So if your if you try and write the new field to your database and the database schema doesn't support that field, very strict, very rigid, boom, you're going to get a database error and the application is going to crash. Over here, we got more flexible fields. You can give me a field, you can ignore it. It doesn't matter. It's always allowed. You can not give me a field, or you can give me a field. Over here, you have to very strictly defined. This is required or it's not required. Very strict, very rigid. Over here, more flexible. Whether it allows nulls or not allow nulls, so on and so forth. Over here, you got primary keys that auto-increment. And we went through the problems with primary keys that are auto-incremented. Over here, now check this out. This is an important piece. Primary keys have an identifier _ID. You guys saw me start to use that syntax, _ID. And in Mongo, all of our primary keys, what's a primary key again? Someone tell me what a primary key is? Yeah, a little bit more though. You're right. It helps you link tables together, right? That is true. But within one table, what does a primary key do for it, for that table, or within that collection?
The index.
Not the index. An index is like on a book for performance. Like you can look things faster, you can look up things faster with an index. But you're right, it is an index by default, so I think that's what you're saying. What is the purpose of a primary key in a table or in a collection, as we're now calling our tables? What is the purpose of it?
Accessing data.
Not the primary purpose.
To identify each
Bingo. Say it again.
row.
Say it again.
Identify each row.
To uniquely
Uniquely.
identify each row. So what's the purpose of a primary key?
To uniquely identify each row
Within a collection, yes.
in a collection.
So, has there ever been like one with the same primary key? Like, is there like a chance?
Okay,
Is there a chance? Isn't it randomly does it?
let's answer that question. Okay, before I answer that question,
Oh.
what is the purpose of a primary key?
Alright, I'm gonna try it.
To uniquely identify each row. Yes.
In a collection.
In a collection.
Unique identifier.
So it is a way to uniquely identify each. Now let's use.
Like our social security numbers are primary.
That should not be used as ID
Why?
because it has a maximum limit pretty much of.
Yeah, you would think that it would be, but yeah,
It's
there's a
dumb.
case that could be made against it.
It's dumb.
But it does uniquely identify us
It to the government.
to the government. Okay.
That's the issue.
Oh, bet.
Is everyone at least temporarily on board with what a primary key is? Let me get a visual nod your head up and down if you understand primary key. I'm looking for everyone to visually nod their head up and down. Jacob, Christopher, James, do you understand what a primary key is?
Nonverbal gesture.
Drew, you understand what a primary key is? Okay.
Drew, are you sure?
Please listen.
Sometimes I just gotta figure out if I'm getting anything through. I'm trying my best.
I'm not involved with this.
I appreciate that.
I'm not involved with this.
I appreciate that.
Any more dad jokes?
That's all I got.
Bro,
Collection of documents is all I
bro,
got. That's
bro, like, that joke's gonna help me remember this. Now.
well, I'm gonna
I hope
tell you what.
know.
If you did take, I might have lost half of you, right? I lost a third of the class
Oh
or
no.
whatever.
You
Moving
know
on.
Even more.
Moving on. Trey, you asked a question. What was the question? Oh, in theory, could you have two values that were matching that were in a primary key column? Right? That's what you asked me. In a relational database, no. There is a strict rule. It's called a primary key constraint. A constraint is just a rule on the data. And a rule on the data that says, hey, if it's in this column, they can't match. So in a relational database, you cannot have two primary key values that match. Okay, now, that's in a relational database. Let's talk about non-relational. Okay, let's go back to here. Okay, this is a unique string that is an object ID. This unique string is so unique. You got a random number generator here. I want you to imagine,
RNG.
and the odds of two random numbers being generated are so small,
But it's a chance.
but there is a chance.
There's a chance.
There is a chance. It's a non-zero chance. Okay? Now, how small is it? It's something like, it creates so many, it's like something like the number of atoms in the universe. It is so astronomically small, you could basically say it's not going to happen. But it can.
It's not zero.
Okay? So it depends. It's a really good question because the question is, can you have two matching IDs? And the answer is basically no. But in this system, there is a one and I don't know, like no, it's not going to happen. But it could, in theory, it could happen. Okay, when you have these relationships in relational databases, you have foreign key constraints. Remember, we talk about the performance issues with foreign keys. It introduces performance issues. MongoDB cannot enforce foreign keys. You can have foreign keys, you cannot enforce foreign keys. And that's actually a good thing. Now, if you were concerned about the odds of that happening, and it was such a small odd, there is a solution in Mongo, is that you add what's called an index. Back to, first off, what is a constraint? A constraint is a rule on the data. What rules are you putting on the data? That's what a constraint is. Unique constraint, of course, is going to enforce that all of the documents, if you will, have unique values for that particular piece of data. And so you can add a unique index, which is going to enforce a rule on the data. So it is possible on both sides to change my answer a little bit. You can enforce uniqueness, yes. But do you need to?
I wasn't worried. I was
Just asking. Yeah, I'm with you. I'm with you.
Curiosity killed the cat. That's what they say.
Finally, we are going to work a little bit with indexes, and this is a performance thing. Indexes are performance. Here's the TLDR on indexes. If you have a query that you're doing all the time, you want to optimize for performance, you're searching Spotify by artist. Okay, you want to make sure that query is optimized in your database so that you can look up artists quickly on that website or on that app. Okay, you're going to go into the collection of artists, and you're going to find artist name, and you're going to put an index on artist name so that you can look up artist names quickly. And you can see, again, indexes speed up operations on a particular field. They are vital to application performance, and the same thing, there are indexes in MySQL, they are vital to application performance. So if you're running queries, and again in Mongo, there are optimizers and things to tell you that, hey, your users are searching for this particular thing all the time, so you might want to build an index on that thing because of performance. Let's all do some things. If you're on slide 33 with me, we are going to click on the download page for Mongo Community Server. Mongo Community Server is essentially running Mongo locally on your machines. Is everyone with me? Go ahead and click on this link. And click the big green download button. I'm going to save it, and let's download Community Server. Yeah, while that's downloading,
School's Wi-Fi runs in knees.
it does make sense to have a local database on your machine, but it also makes sense more so in 2023 to save your database in the cloud. So while we are downloading Community Server, that is a local database, very quickly we're going to transition to the cloud. Because why save things on your computer when you can save them in the cloud for any computer to work with? So that's just a note. In this class, we are going to primarily work in the cloud because it's 2023 and that's what makes sense. Okay, here we go. Many students have finished their download. If not, you can take these steps later. Let's go ahead and run the MSI installer. Now, whether I've done this in the past on my machine, I will find out. MongoDB version 701. I accept the terms. Read like the matrix. Sure, we're going to do a complete installation. And default here, default directories, default service. Notice here it's a little checkbox to install Mongo Compass. We'll talk about what Compass is. It's your GUI. Click install. So during this installation process, there's an administrative prompt that you have to approve. And if you overlook it, it's a little shield down in the taskbar. Okay, and you have to click yes, I approve. Otherwise, this will hang and not install. So keep an eye out for that little shield down in your Windows taskbar.
You may have to resupply us soon, Mr. G.
Okay, let's look at this. So this is Compass, and this is the GUI, graphical user interface, for the local databases. You can also connect with Compass. You can also connect to cloud databases, so it doesn't have to be local databases. And so you can kind of see by default here, it's going to connect to localhost, and it gives me a port. And let's just click connect and see what it does. And here we are. We're in a local database, and we've got some databases down here that we're not really going to mess with. But if I wanted to create a collection, let's go ahead and create a database. I'm just going to call this Rankin Database. And my first collection, again, think of a collection as your table. I'll say students, create a database. And there we go. I got a Rankin database in our first collection of students. And if I want to add my first document, I'll say given name Evan. Family name. Family name not in quotes. Family name not in quotes. And no, this is not me. This is Evan Meyer. Now this is more of a searching filter. That's why there's a find button. So this is not an insert operation. So if I wanted to maybe add data, I would click the add data, insert a document. And here you can see this is my object ID here. I'm just going to take that out and just kind of put that in here. You do not have to follow this. Inserting not permitted. So I'll just delete everything, all the boilerplate, and say, oh, I don't know if it wants me to insert an ID. I'm not used to using this, obviously. I'm much more familiar with the command line, which is first name, or I always want to say given name. What's up, Jack?
I think I figured something out.
What'd you figure out?
You want to restart it and then put it where it says enter document here, like numbers up top.
Do what now?
Hit enter document.
Insert document.
Page one where document is where you want it, where it's
What?
the name.
I'm just going to
And then
Macaroon.
line two.
I'm just going to
On line 2?
Yeah.
Like this? Like that? In the comment.
Maybe get rid of the comment.
It does look like that's just a comment though. So let's
It doesn't error out me, but we're comment.
it doesn't error out, correct. But it did not put in the data. So if we edit this, there is more of a manual process this way. Again, we're not going to be add another field. Here we go. Family name Gudmested, and there we go. We've updated a document. Using this, insert document. Maybe I forgot my. Maybe it requires quotes. Okay, not gonna battle this right now.
Maybe do it in curly brackets on its own.
Are you guessing or you know?
Well, I'm just basing it off of what the shell earlier. Like within the ID, it has. Okay, so it's like
This is yeah, this is an object nested inside of an ID. Yes.
I just went to Mockaroo and I just imported that with a JSON file.
Which is another option, right? You
That's
could
just-
import a JSON file from Mockaroo, and that would be a different way, right? But just manually inserting a document.
Oh man, I'm too lazy for that. I am a programmer.
Not important at the moment. Let's finish it. We have it up and running. Now here's what I'm going to recommend. Once you have Compass running, let's pin it, right? Right click and pin to taskbar. Okay, so that we have Compass up and running again. That way we have it quickly accessible. If we close it, we can just run it. I don't need the shortcut on my desktop anymore. It is now down there. There's also a command line tool that will install. MongoDB, Compass, we've already installed Compass. Mongo Shell, okay, so this is the next step. The Mongo Shell allows you to query and update your database through the command line terminal. The shell is a command line. This is what we're going to be doing this in our labs. We're going to be using the command line interface. The reason for that is that even though this says warning, shell commands use a slightly different syntax that we'll be using in Node. They're very similar. Okay, the syntax between the shell and the JavaScript that we write in Node is very similar. So let's go to Mongo Shell documentation. Again, there's a link right here. Click on that link. Yeah, Mongosh. That is correct. That is correct. So learn how to download and install, not the binary. So let's go ahead and click on this link right. I don't think there's a download link right here. Right here. Mongosh is available as a standalone package. So let's click on that. Okay. Well, it's right here. To learn how to download and install Mongosh binary, C install Mongosh. Let's click on the download center. Okay, there we go. When you click on the download center, we get access to the Mongo Shell download. Here's our green download button. Okay, this is This process is going to be a little different than the last one. The last one was pretty easy, just installing defaults. Probably we're going to have to modify a path, just like we did last time. Now, and also everyone realizes this is a zipped folder. Okay? So let's start by unzipping. So I'm going to double click the zip folder and I'm going to click extract all. So let's extract all. Notice where it's extracting into downloads. I mean, I'm fine with that, but this is where the executable will live. The executable itself, the Mongo shell, will live in your downloads. If you don't want that, you can move it to documents maybe. That might make more sense in my opinion, but it's up to you if you want to move it or not. Okay, I'm just going to keep it in downloads. Okay, now this is clearly not the zip folder. See the icon's different? There's a different icon for a zip folder and an uncompressed folder. But if I go inside here and I go inside bin, this is Mongosh exe. I can right click, run as administrator. And Windows thinks it's a virus. We want to run anyways. Again, so if you run it as I think you can just open it or run as admin. Either way should be fine. I'm going to run as admin because that's what I am. I'm going to click on more info and I'm going to run anyways. I get this little defender down here to give you permission. I'm going to click on yes. And now you hit enter and you're in the command prompt. Okay, show dbs is our first command. Show d. Oh, we got some hands up. What's up?
Mine is just giving me that.
I forgot to put a space between my show and dbs, right? Show databases. We've got RankingDB. That was the one I created, right? So our first command is show dbs. Again, we're going to have a whole nother lecture on commands.
I'm so excited.
Right? Let's do use RankingDB. Now we get the little prompt that says RankingDB.
Do you want us to do this?
No, you don't have
Okay,
to.
I'm doing it.
If you hit show collections, you can see we have a students collection. db.students.find is our find method without any parameters is selecting star. I've got one document with one key and value. So this is in the SQL world, this is select star from students. Remember SQL, yeah? Find without any sort of information inside of it. Okay, the next thing I'm going to do, now that I'm inside of Mongo shell, I'm going to right click and I'm going to pin this to my taskbar. So I have compass and the shell. I've got the GUI and the command line pinned. If I close that, now because my resolution is so doggone small, let me see if I can unpin this stuff. I'm going to unpin you. What's chat? See, you can't unpin some of these. That's annoying. I've got the shell and I've got the other one. Okay, let's do one thing. See this bin folder? Copy that path to your bin folder. And just like I did the other day, I'm going to add this to my environment variables. Because right now, if I go to the command prompt and I type in Mongo shell, this should be, here I lied. It is already added. Do you guys get a recognized command? Does this work?
No.
It does not work? Okay. So here's how you get this to work. Okay? If you go to a command prompt and type in Mongo shell, you need to add this to your environment variables, just like we did the other day. I'm going to type in the word, I'm going to type in environment, edit the system environment variables, So at the Windows prompt, I'm going to click on that button, click environment variables, click on the path system variable, click on edit. Now notice mine's right here. I've already got this path to my bin folder. If your command's not recognized, it's because your path was not updated here. You would just click on new, and then you would paste that directory in with the backslash at the end and click OK. Click.
We need to move it out of the downloads folder, don't we?
That is your option. You can optionally move it out of downloads. I think that makes sense, but that's up to you. Okay? You would then click OK. I'm going to click on cancel because I already have it there. Click OK, click OK, click OK. Close your command prompt. Close your old command prompt. Open up a new command prompt. Type in Mongo shell, and you should get it as a recognized command. Good. Yes. Okay, we now have Compass, GUI, Mongosh, command line. We have a couple ways to interact with Mongo databases and collections and records and properties and fields. Bless you. Okay, last but not least, what we will use the most of, well, we're going to use a lot of shell to learn the commands, and then we're going to use a lot of Mongo Atlas. And so Atlas is a cloud hosting version of MongoDB. Okay, this is just done by mongodb.com. So go ahead and go to mongodb.com. And you need to register. You need to try it for free. Going to recommend you do not use your inside ranking emails because you don't have, those are not forever email addresses for you. So I'm going to recommend using a Gmail. Go ahead and register for an account.
What company should we put?
You can put Rankin if you like.
Rankin?
Click on sign in Google.
And go ahead and register for that. I'll pause while everyone does that. Now you're going to get to a point where we need to click on like the button that says free, right? If you want to pay $57 or $95 a month, you must have too much money. And giving it away, it might be in your best interest. I don't know what to tell you. But you probably want to choose free. Okay, so I'm actually going to stream this because I've already done this, so I'm going to stream another student doing this, and that student's going to be Trey.
Oh, I'm the lab rat?
Trey is the lab rat. So Trey, if you would, go ahead and share your screen.
All right, hold on. Okay, I gotta open up Discord now. Let's see. All right, Tony. I guess I'm no longer siphoning off you today.
So Trey is now on Discord. And can you, he's now streaming. Let's watch his stream. Okay, this is the screen where Trey has chosen the free option. It looks a little different than it used to. Now, the next is the provider. I always recommended AWS as opposed to Google Cloud. AWS, I mean, it makes no difference. Or you could do Azure. So do you want Amazon, do you want Google Cloud, or do you want Azure? Let's just choose AWS. Let's choose our region. So let's go ahead and get the closest region to us.
Ireland.
Which is going to be either East Coast or West Coast. I don't see anything closer, huh? So what's closer, Virginia or Oregon?
It would be Virginia.
Okay, Virginia. Let's go Virginia. Okay.
Oregon's all the way.
I think mine's completely different. I didn't even get the option of choosing pathways.
Okay, hold on, Trey. Okay, Tony asked a good question. What does it mean when you're selecting a provider? These databases are going to be stored on someone's computers. That's what the provider is. Are these Amazon computers? Are these Google computers? Or are they Microsoft computers? So when you're saying you're saving information in a cloud, that just means you're saving your information on someone else's computer. And the provider is who owns those computers. And they're called servers. You call them a computer, but I mean ultimately a server is just a computer. Cool?
A really big computer.
Now, Trey was being silly with his name, so let's delete that.
$1,000.
It says you cannot change the name. Okay, so
Once you make
you're not saving your information on one computer. It's a cluster of computers. Therefore, you get a little redundancy, right? So if one computer craps out, your data is also saved redundantly on another computer. So that's why it's called a cluster. You're not just saving your information across one of Amazon's computers. It's probably on 3, if maybe 5. I don't know, right? So you get to name your computers. It's called a cluster. Call it cluster 0. Let's just call it cluster 0, Trey. I appreciate that. And leave those tags off. Click on the word create.
Oh no.
Select the cars.
Oh god.
Okay, this is an important next step before we move on. We're gonna wait for everyone to get here. Okay, Trey, if you scroll up for me. So the next step is security quick start. Hey Jacob, do you have the quick start link under security? On your navigation, see under security, there's quick start. You're gonna have to click off of that screen. On the left-hand side, under security, is there a quick start? No. Okay. So go back to your database access tab. We're gonna click username and password.
My password's been made. Let's do this. It's so over.
So here's what I'm gonna recommend. Username and a password that you don't forget. Okay? This is up to you, but I cannot help you with this. I cannot help you remember this. This is on you. This is your admin account. Okay, so Trey's admin account is Trey Pointer, and he has hidden his password.
It was unhidden.
And so remember this. Remember these credentials. It can be changed. Okay, you're not completely out of luck.
That's great news. If I'm streaming.
Now it does say this password contains special characters which will be URL encoded. That's fine. Go ahead and click create user.
Oh man.
Where did you go? Scroll back up.
I would from my local.
Okay.
No one from up here.
Okay. So there we go. Trey has a user. This is his admin password. This is good. Scroll down just a little bit next. Where would you like to connect from? Okay. We're going to click on my local environment for now.
Do you guys want me to link the right good IP?
Do you see the add my current IP address button on the right?
What is it?
Yeah.
Okay.
Oh, it actually has already done that. It says we have added your current IP address. We're going to change these settings as we go through. Go ahead and finish and close.
And there it is right there.
Congratulations, setting up access. That's it.
So just go to overview.
You can go to overview if you like.
See.
Okay, hang tight.
Are we-
Okay, so we're going to do a few more things.
Do you want me to keep on streaming?
You do not have to keep on streaming.
Alright, cool.
So if you guys want to hop back on my stream, look at my screen. And what I'm going to invite you to do is just kind of go back to the MongoDB.com. I guess cloud.mongodb.com. It's going to put these it's going to route you, even if you go to the home page. But it should be something like where you see cluster 0. Can everyone kind of see cluster 0? Okay, so let's get the lay of the land here and kind of see what's going on. The first thing to kind of realize is that you have different organizations, but these are personal to you. My organization is called Evan Gudmestead Rankin Technical College. And so this is just a unit to collect projects in. Now, on this drop-down list, I have different projects. I've got issue tracker V2. I've got one called MFlix. What do you guys have under projects?
Nothing.
Nothing.
Project 0.
You have a project 0?
Project 0.
So when you say nothing, but there is a project 0.
Sorry.
Okay. So you guys have project 0.
Okay, you're lying.
Let's go ahead and create a new project. So again, organizations have many projects in them. And let's go ahead and create a new project. And I'm just going to call this sample DBs. Click next. You should have permissions. I am the project owner. Go ahead and create project.
What's the name of the project you like?
Sample DBs.
Wait,
Sample.
Oh, sample DB. Okay, I was like, Samuel? Okay.
So I'm now in sample DBs, and I'm on this overview screen.
Would you like us to invite you?
No. Different projects have different clusters, so it looks like I need to go ahead and create my cluster again. Because you did a cluster on project 0, right? So let's go ahead and create a deployment.
Oh, yeah, sure, yeah, we gotta go through all of this now. Is there a certain name?
Well, wait a minute. Now, so you guys should now have sample DBs and project 0, right? Okay. Go back to project 0. And I'm actually gonna use someone else. Tony, do you want to stream for me?
Yeah, Tony.
I don't see a purpose to create a new project if we could just use project 0. So, Tony, if you would in Discord.
I'll be honest, I forgot how. Oh, here we go.
You see it? It's just a button. You just got to find the button.
So how am I supposed to reload all of the stream now, Tony? How am I gonna
Okay.
reload the stream?
Okay, so everyone can see that Tony has a organization called Rankin Technical College. These organizations, like even if you had one called Rankin Technical College, they're not gonna like combine. These are unique for you. These are okay. So then Tony is on project 0. Okay, and probably we're just gonna delete sample DBs. But now that we're on project 0, don't worry about that now. Don't worry about that now. Let's click on the load sample data. Okay, it says deploying your data. We are loading your data set to cluster 0. Hold that there. Just let that spin. There's a preset of dummy data that we are loading here. And we're going to work with this dummy data to learn. So if you guys get to this point where you're loading the dummy data, I'll pause and let that finish spinning. Okay, so it just finished and it says sample data set is deployed. Let's click on that X. And let's click on, in the left-hand nav bar, we've got the database link. And let's click on the Browse Collections button. And here we see our sample databases. These are different databases: sample Airbnb, sample analytics, sample geospatial. These are different databases. And so go ahead and click on sample mflix, for example, and expand that. Okay, so the database is called sample mflix, right? Netflix, if you will. And we have various collections underneath that. We have comments, movies, sessions, theaters, users. Okay, for the example, go ahead and click on the movies inside of our sample data set. And there you see our first movie's title is The Great Train Robbery.
That sounds, oh yes.
Go ahead and scroll down. You can see many, many movies. This is 20 documents, if you will. You can see one of 20. Go ahead and click on Next in the lower right-hand corner. So you can see 21 through 40. So there are lots of records, okay?
That's my favorite movie right here. The Italian.
Now, Tony asked a good question. He said, Mr. G, we created a username and password. But that's not like for the website, right? So what is that username and password for? And that's to connect to your cluster from your application or from your command prompt or from Compass. Okay? So let's do that. Now, Tony has a username and password. Clearly, we're going to remain that encrypted. But go ahead and click on your Atlas homepage there. Yeah. So in the upper left-hand corner. So these are the projects. Let's click on Project 0. Click on Database in the left-hand tab. Oh, you know what? I found what I needed. Okay, so I had you click around there. But what we're looking for is this database in the left-hand nav bar. So everyone get to this screen. Okay. Click on Connect. This is going to be to connect to our Mongo shell. So go ahead and click on Shell. And on step number 3, it says run your connection string in your command line. So Tony's going to click on the copy button. Okay, he's going to open up a command line terminal, CMD. Click on Start, click on CMD. He's then going to right click in the prompt, and that's going to paste. And he's going to hit Enter. You can see the username's already in there. He's going to type in the password. And now Tony is connected through the terminal. Now let's run the command that we learned, show space dbs. Enter. These are our databases. Let's now type in use space sample underscore mflix. MFLIX. Enter. There's sample. Now you can see we are now using sample. Type in show collections. Show space collections. Type in db dot movies dot find parentheses. Enter.
Whoa.
Hey, there's some data.
That's a lot. I cannot read.
Okay. We're going to learn how to write some queries in Mongo on our next lecture. Okay, but this is the lay of the land, right? Mongo Atlas has organizations, they have projects. Now our project is called Project 0. The user that we created was for Project 0 cluster. Okay, if we created a new project as we started to do and we backed out of that, we would have to then create a new username to connect to that other project, okay? So I didn't want to do that. We'll just use Project 0. Project 0 is where our sample data will be found. And because this is free, you can only have so many databases under a project. And so we will create multiple projects because we just loaded a whole bunch of databases under this project, and we would hit a limit pretty quickly if we tried to do too much more under Project 0. Yes?
So since we're going to be in the Google Cloud, or like at one point in time for this, are we going to be selecting Google Cloud instead of AWS?
It really, that will not be a factor that matters.
Okay.
So we are using Google Cloud to host our application.
Okay.
You can host your database on a different provider, no conflicts.
Azure, let's do it.
Yeah. So that's a good question. So like our backends right now are deployed to Google Cloud, right? But our database can be deployed to Amazon, no conflicts. All right. This is a whole lot of new stuff for one day, right? So I'll go ahead and stop my little recording here. And like I said, what's coming next is we're going to learn to write a bunch of queries against this database.